Enterprise adoption of autonomous agents is accelerating, but these systems often stall when they reach the perimeter of financial reporting. Putting a large language model in charge of a financially significant process, like routing invoices or processing journal entries, creates immediate friction with the Sarbanes-Oxley Act. Faced with this friction, auditors who treat every AI model as a high-risk entity create a compliance backlog that prevents specialized, low-risk tools from reaching production. The reality is that existing IT general control principles still work. The solution lies in expanding the current control scope, not inventing a completely new one. The friction we see doesn't actually stem from the AI technology itself. It comes from systemically misapplying legacy audit assumptions to modern, non-deterministic systems. This diagram shows the structural difference we are dealing with. On the left, we have a traditional deterministic software stack: database, logic, and user interface, secured by a standard IT general controls padlock. On the right, an LLM agent system: model, prompts, retrieval-augmented generation, and tools. Notice the open, shifting nature of the right side. When auditing the traditional stack on the left, the primary question is binary and straightforward: who changed the application code? That question fails on the right side. AI agents do not rely on static application code to determine their final output. To govern these systems, auditors must adapt their heuristic. The question expands from who changed the code to what can alter the agent's behavior. Behavior can be altered by a variety of non-code elements. A tweak to the system prompts, a shift in the underlying model version, or an update to the documents in the knowledge base can change how the agent performs its task. By shifting the focus from code modification to behavior modification, auditors map existing IT controls directly onto these new technological nodes. Compliance is maintained without breaking the system. Applying full IT controls to every AI implementation creates compliance bloat. Treating a tool that simply summarizes accounting policies with the same rigor as an automated billing agent is inefficient and unnecessary. To prevent this, we classify AI agents using a vertical risk ladder, consisting of 3 distinct tiers of autonomy. Level 1 is the advisory agent. This agent only provides suggestions or information. Because a human independently reviews the output before taking action, it has minimal SOX impact. Level 2 is the decision support agent. Here, the agent analyzes data, and a human relies on that output for a financial decision, like flagging unusual journal entries. Auditors must scrutinize the data sources and validate the information produced by the entity. Level 3 is the autonomous agent. This agent executes transactions without human intervention. It acts as a digital user in financially relevant systems, representing the absolute highest IT control risk. Audit rigor scales with the agent's influence on financial reporting. The specific technology used is less important than the agent's ability to modify a ledger or influence a manual control. Let's focus strictly on Level 3 to see exactly how traditional controls stretch to cover these highly advanced autonomous workflows. This flowchart illustrates a standard Level 3 financial process.
An invoice comes in, the AI logic determines the accounting, an SAP journal is created, and finally, the system routes it for approval. Applying traditional change management here means expanding our definitions. An edit to a system prompt or a version bump to the LLM are now material changes that require formal authorization and testing. If an external vendor updates their GPT version, management has a responsibility. They must prove that existing controls and financial outputs still operate as intended, despite the underlying model shift. Next, we apply logical access controls. The definition of access expands to include the agent's knowledge sources. You must strictly restrict who can modify the vector databases or SharePoint sites the agent reads from. Securing these systems also requires rigorous credential management. Embedding hard-coded API keys or service accounts directly within system prompts is a major SOX failure. Securing a Level 3 agent requires applying traditional change and access rigor to entirely new types of unstructured data and external API dependencies. Beyond what the agent knows, auditors must govern what the agent can actually execute. This requires strict oversight of the tools and connectors the AI uses to interact with downstream applications. Here, we see a segregation of duties matrix mapped to an AI avatar. Just like a human employee, the agent has specific functional pathways, one to initiate a transaction and another to approve it. An agent must never possess the system privileges to both initiate and approve the same financially significant transaction. The logic of incompatible access combinations remains exactly the same. You must also establish clear incident management protocols. Ask yourself, what happens if an agent fails, goes offline, or produces incorrect outputs that circumvent key controls during a financial close? An agent with right access to financial systems functions as a digital user. It requires the same segregation of duties and privilege constraints as any human controller operating within that same environment. Auditors and IT teams must take a defensive posture regarding how they structure this oversight. There is a serious danger in trying to force qualitative AI performance metrics into rigid, traditional control frameworks. To keep the framework defensible, we use this three-pillar architectural stack holding up our financial compliance roof. The pillars are traditional GITC, AI tech controls, and business controls. The middle pillar, AI tech controls, is designed specifically for model governance. Its scope includes hallucination testing, bias evaluation, and prompt injection resilience. Notice the hard operational boundary between the traditional GITC pillar and the AI tech controls pillar. They do not overlap. SOX controls require binary evidence. Either a control worked or it didn't. Trying to apply those rules to the probabilistic nature of model hallucinations makes it difficult for an organization to consistently demonstrate compliance. Finally, the third pillar, business controls, handles the application level, ensuring proportional human oversight and the final validation required for the financial outputs. By intentionally separating traditional IT controls, AI-specific technology controls, and business controls, organizations can ensure rigorous SOX compliance over financial reporting without suffocating their ability to innovate with new AI.